Hello, hello, and I have another Zippular line puzzle. So they're modular sum lines. And this one is The Rock Shadow by Heliopolis, part of his Zippular Line series. And yeah, let's just get into the rules. So normal Sudoku rules apply. That means the digits 1 to 9 are in every row, every column, and every marked 3 by 3 box. We also have these zippular lines. So a zipper line, which is kind of what these are a play on, have every digit that are an equal distance from the center away from each other. So I could color these, say green, and maybe these will be gray, blue, peach, and pink. Each pair, if I sum them together, if this were a regular zipper line, these will all have the same sum as each other. So the greens would sum to the same number as the grays, the same number as the blues. And that would also be the same as the digit in the center if there was a single digit in the center. So I call that purple. This purple would have the same, this digit would be the same as the sum of the pinks, the same as the peaches, etc. With zippular lines, it's not the same sum, but the same sum mod 3. So if I think about dividing the 9 digits into modular groups, right, we would have 369 in the 0 group, 147 in the 1 group, and 258 in the 2 group. But obviously, the numbers can go higher than that, right? So these blue digits could add up to 15, and that has a remainder of 0 and divided by 3. So that would be in the 0 group. So basically, each of these sums and the purple digit in the center they're all in the same, they all have the same remainder. They're all in the same group, where the groups are defined by their remainder mod 3. So that's how the zippular lines work. We have x's, xv, so everything across an x sums to 10, and that's not modular, that's just a sum of 10. This one is going to be a sum of 5. And then we have Kropki dots. And so in Kropki dots, if you are across a white Kropki dot, the digits have to be consecutive. So, one is one more than the other. If you're across a black dot, they have to be in a 1-2 ratio. So if this were, say, a 4, then this digit would have to be either a 2 or an 8. So those are the rules. So let's go ahead and reset this and get started. Um, so these setups here remind me of I can't remember if it was NKEG or a different one of the Zippular line puzzles, where it was very helpful to think through these as having remainders that are one away from each other. And in particular, yeah. So these are all going to be different modular groups because if you add one, you by definition have to get into a different group. So actually, these two are going to be in the same group. I don't know what that group is. I'm going to call it blue for now. But these are in the same group because like if these are either going to go up by 1 or down by 1. And if I do that 3 times, I'll end up with back in the same group. So these are going to be the same as each other. And if I follow this line to its end, all the way over here, that means that these are also going to be in the, oh, and they're across an X. That's nice. Okay. So these, I don't know that they're the same group as blue, but they're definitely the same as each other because these are the same as each other. And so how do I get 10 with 2 digits that are in the same group as each other? The only way to do that is 2, 8, because 1 and 9 are in different groups, 3 and 7 are in different groups, and 4 and 6 are in different groups. So this is a 2, 8 pair. And I think I had another thought here that these differ by 1. Oh no, I had a bad thought. I was thinking these have to also differ by 1, but that's not true. They have to differ by 1 modular group. Which is not as helpful. So I don't think I can distinguish which these are yet. But I do know that these are in the 2-8 group and that these are not. So I'm going to uncolor this because I don't know what group that is. And I'm going to define the 3 groups as, let's say, blue, pink, and green. And then I don't know what these are, but this group is the complement of pink, whatever that is, which means this group is also the complement of pink. The other 2 groups are blue and green. And these 2 are off by 1, which means these 2 are off by 1. I mean, basically this has to follow kind of an inverse pattern from this because at the other end of this line. And so This is going to have to be green, I think, because it has to not be blue because these differ by one, so these differ by one. It also has to not be pink because these differ by, well, these differ by one, so these differ by one. Right? I mean, this is different than these two, so this is different than these two. Yeah, that's definitely green. So we're starting to build something here. These are either 1, 3, or 7, 9. But I don't know which way around it goes, so I don't know that that's so helpful yet. 5, I need 1 from each modular group here in the Kropki dots because I have a difference of 3. Or another way to think about that is I can't have a 1 in here because I can't have a 2. I can't have a 9 because I can't have an 8. And I can't have 8 or 2. So these digits are between 3 and 7, which means they have to have a 5 in it. So the 5 is in here, which means neither of these are in the 285 modular group, which means this one is, because I again have this 3. Oh, these both are actually, because I have this, these sets of 3s. These are, like one of these is in the 147 group, one of these is in the 369 group because 258 are all taken. So, and in fact, this is either 3, 4, 6, 7, and these are the other ones. Interesting. So these are a 1, 9. Because I can't, again, have 1, 2, or 9, 8 here. This is a set of 3. It could, in theory, be 4, 5, 6, but if it were, that would completely break this because all that would be left is 1, 3, 7, 9, none of which are consecutive. So this is either a 3, 4 pair, making this 5, 6, 7, or there's a 6, 7 pair, making this 3, 4, 5. So actually, this becomes 4 or 6 only. And then these are both going to be pink. One of them is going to be a 5. Yes, so either going to be 5, 4, 3, 2, 5, 6, 7, 8, or the 5, 4, 3, 2, 5, 6, 7, 8. That's how these 4 digits are going to work. And these differ from over here. I don't know which this is yet, so I don't know that I can do much with this yet. Except that I can say what these two correspond to these two. Yeah, that's not so helpful. These two are in the same group, but I don't know how to use that yet. That means 5 is one of these. This is either green or blue. This is the other. Oh no, I don't know. This could be blue and that could be blue as well. Yeah, no, I don't know how that works yet. Okay. I feel like I'm running out of steam here. These correspond to these. So these are the same. Yeah, of course, these are the same group. That's how I knew these were. These are the same group, but what group is it? So these are now tied by this 2-8 pairing. So if these are in the 0 group, that's 2, 5, 8. If this is in the 1 group, that's 3, 6, or 9. If this is in the 2 group, that's 1, 4, or 7. Saying that out loud to stall as I think about where to go next. Okay, I can do more here. These can't be 4 or 6. So, right, these are either 3, 4, 5 in some order, or 5, 6, 7 in some order. I guess I'll put 2, 5, 8 in here just for completeness. 5, 5, 2, and 8. One of them's up here. It could both be up here is the problem. Trying to think if I can say something about these because there's one of 2 different kinds here. There's one of 2 different kinds here. So at least something's doubled here, but that's not enough to. It's not enough to do anything. At least that I can see. Oh, can I do something with this? So if this is 6, this could be 5 and then a 1 group, or 7 and then a 2 group. If this is 4, this could be 3 and a 1 group, or 5 and a 2 group. Wait, is this not 3, 6, 9 either way? Oh yeah, because these are different groups. These are different groups. So this is not 3, 6, 9. This has to be, because this is 3, 6, 9, that's 0. 0 plus whatever will be itself. So these have to be the same. If this is 0, these have to be the same. So this could be 3, 6, 9. No, because it could be 3, 4, 1, 7. Yeah, okay. So So this isn't 3, 6, or 9. Does that help me at all? I don't think so. One of these is the 3. Oh, this is 4. Oh, this is 1 or 4. Here we go. Green is the 1, 4, 7 group. That is what I needed. I should have looked at the black Kropki dot right away. So this can't be 3, 6, or 9 because to put 3, 6, or 9 on a black dot, it has to be 3, 6 pair. They'd both have to be green. So this is 3, 6, 9. So how does that work? This is going to be either 1, 2, 3 or 7, 8, 9. Okay, now does this help me do anything up here? Probably not. Yeah, because I don't know what this is yet. Once I get this, I'm going to get all the modular groups over here too. I still don't know this, right? I feel like I should, but I don't think I do. Because this could be 4, 7. 4, 2, 7, 8, 9. Yeah. Oh, yeah, and that would make this one. Yeah, that's okay. That's okay. So what am I missing? One of these is a 5. This is 9. We get 9, 3, 2, 1, 4, 8. Perfectly reasonable. Maybe I should color these in different colors just to see what happens. Oh, I don't want to though. I feel like it's not going to be so useful. I'm going to do it. So I'm going to call these purple, peach, yellow. Probably I don't know that these are the same. If I knew these were the same, I could repeat this complement pairing over here, but I don't know that's true. So what am I supposed to do? Maybe it's something that maybe I have to do some kind of like pseudo set stuff. Um, like what do I mean by that? I know that I know that these digits will all have the total modular sum here is going to be 0. Because whatever this is, it's going to be repeated again here. That's in modular terms, I'm multiplying by 2, I'm multiplying by 3 because I have 3 of them. So these are also going to have, because the whole group sums to 45, which has a remainder of 0, and this has a remainder of 0. These will also have a remainder of 0, but that's in total. That's a lot. I was hoping I could do something like that here. Oh, but I can do that here, right? So this is the same thing. These have a remainder of 0 in total. And on a black Kropki dot, that will also be true because whatever this is, well, one of these is going to be the smaller number, whichever it is, the other one's going to be double it. So the total is going to be 3. So these all together have a modular sum of 3 or 0. So these two as well are going to sum to 0. So they're either different groups. They're either green and pink, one green, one pink, or they're both blue. It doesn't seem that helpful to me, at least, yet. And can I do something with, like, same thing here? No, but this is 7. I mean, I could cut it off here and say these all together have a modular sum of 0. So these have a modular sum of 0, but only when combined. It seems. Oh, hold on. But these also, when combined, have a modular sum of 0. I feel like we're close to something here with something like this, but I can't quite see it. So these 6 digits have a modular sum of 0. these digits all have a modular sum of 0. So let's just highlight. So I'm going to highlight this. Let's highlight this. I don't know how you call this. Um, whatever. And then I'm going to color these lines here. This nice green color. Oh, but those don't go well together. Also, red green's a colorblind thing, right? So let's do. I think red blue is pretty innocuous. So I know the modular sum of the reds is 0. I don't actually know the modular sums of the blue, but I know that it's 2 sets of 45 if I count this twice. So the modular sum of the blues together is going to be 0 minus this corner. So I think I'm going to get a relation between those two cells, but it's hard for me to, without a paper and pencil, it's hard for me to figure that out. So these are, well, the blues are 0 minus blue, minus this blue. And the reds are 0. So if this is 0, yeah, I actually don't think that's helpful now. Well, hold on. Maybe this can't be 0. I was thinking if it's 0, this could be anything, but maybe it's the opposite. Maybe it can't be anything if it's 0. Hold on. If this is, or maybe this also has to be 0. Maybe these have to be the same. But I don't see why yet. Well, these digits. Oh no, it's got to be twice this. Okay, so these have to be 0. These together have to be 0 minus 2 blue. And these also have to be 0 minus red. Because when I add red to these, if I add red to these, I get 0, because that's 0. If I add blue twice to these, I also get 0. So blue is in some sense 1/2 of red, in modular terms, which means, what does that mean? That means that if red is 4, then this is 2, 5, 8. And if what was red is 6, this is 3, 6, 9. So this is not 1, 4, 7. I'm gonna denote that by saying this is blue or pink. Which is not, I mean, that was a lot of work for a tiny little deduction. I just don't know what to do. Hmm. I'm just not sure. I'm not sure. These are either blue, one green, or both pink. But either of them seem okay. This is, oh, can this no longer be, no, it can't. This is 7, 8, 9. Sorry. This can't be 1, 2, 3 because then would have put in the 5. Sorry, that was not so hard. 7, 8, 9, 2. Oh, I still don't know that actually. But that doesn't tell me anything about here, but it does tell me these. That tells me this is 1 and this is 4. Okay, there we go. Now I'm getting somewhere. So this is blue now. And what are these digits? These 5 can only go down here. I still need 3 and 6. Is that right? Oh yeah, 1, 4. So these are green. Interesting. Okay. And these are 3 or 6. This one therefore is definitely blue. I get a blue and a pink here. One of each. I still don't know this, but I feel like I'm very close. I feel like I'm much closer now. Okay, I've got 2 blues, 2 pinks, and a green. No, I don't see it. I don't see it. I don't see next. What can this be? this doesn't have to, I was gonna say this had to have a pink, but it doesn't. This could be 4, 3. Because, yeah, if it doesn't have a pink, it's got to have a green and a blue. Seven's taken. If it's 1, 2, it has a pink. But 3, 4 works just barely. So, but if it is 3, 4, that's 6, 7. And then what? Um, then I get a 1 somewhere and the other pink the other place. Okay. Well, hold on. Nah, it doesn't help. I already know this. I was going to say, I know that I have a blue and a green here. So this is one of each. But I already knew that because I have 3 Kropki dots in a row. That's one of each. I guess I can do more coloring here. Let's see. One. So pinks are purple. Blues are this peach color. 2, 3, 1, 2, 3, 4, 5, 6, 4, 5, 6. These are all yellow. It's messing my head because this is a regular spiral and this is a squiggle. So the shapes here aren't the same, but that's just the way it is. Yellow. Yeah. Well, no, I don't. I was gonna say I know yellow is not 147, but I just know that this isn't one. Which is not helpful. Not helpful at all in determining the modular groups. I definitely have a 9 down here. Yeah, I really want to color these, or which ones? These purple, but that's not right because I don't know that these are the same. This is tough. What is this dot? This dot's now 3, 6. Okay, there we go. Because 2 and 4 are taken. So these are blue. This is a 5. Okay, now we're getting somewhere. This is blue. This is pink. I get 1, 7, 8, 9. My possibilities here. This can't be 9 or 8 because I would need a 7, 8, or 9 here. So this is green. Oh, that's cool. But that doesn't actually tell me this because this could be 6 or 2 or 5. Not 5. It's only 2 or 6. 8's taken. Doesn't tell me the color. So I get one more green. I get one of each here. Okay. I get a purple. These are not the same colors. Oops. Okay. 9, 9. I have a 9 down here for sure. I already know about the 5 here. I have a 9 down here for sure. And either 2 or 8. So 9 is down here with either 2 or 8, whichever one is up here. They can't both be up here. One of them has to be 5. Um, yeah, I'm just not sure. Oh, three's taken. Sorry. So that's 1, 4. These are green. This is not 1. So 1's definitely here. 1, 4. So these, no, I don't know. No. Nope. I almost said 9's over here, but it could be here. And then 4 is over here somewhere. That's not worth marking. Okay, what are these for? These are 1, 7, 8, 9. These are 2, 3, 5, 6. But this is 2 or 5 then. Okay, okay. Sorry, and this is on the rock line. This is on the center of the zipper line. So that's really helpful because now I know these 4 are 2, 3, 5, 6. Can't be 3 or 6. So that's this pink group. I need another pink group here to make it sum to a 1 group. So 2 plus 2 is 4, which is 1. These So, okay, how do I sum to 1? It's either 2 pinks or a green and a blue. Those are the only ways to do it. So these are either both pink, in which case this is another 2-8 pair. So if this is pink, this is also pink. And that makes purple pink. Oh, hold on. This seems promising. I mean, it's probably wrong. Because if these are both pink, all the pinks are taken. So yellow and peach can't be pink. So if these are pink, purple is pink. Purple goes across from pink, which makes this the 4, which is green. So these would be pink. What would peach then be? Peach goes across from blue. So this would be green. And we'd have pink, green, blue. Yeah, that would make this green and we'd be fine. It does work. Ooh. Okay, is there a reason that there's no way I'm gonna, oh, this can't be green actually. So this is either blue or pink, making this green or pink. If this is pink, this is pink. If this is green, this is blue. Right, so we get either 1, 9, 4, 6, 7, 3. If this is green, blue, I get 2 of each of these. This could no longer, or no, it could. This couldn't be green or blue anymore. So this will be pink. And this goes across from, yellow goes across from green, which would make this green. This is green either way. Hold on, did I do that right? That is so cool if that's right. Hold on. There's 2 possibilities here. One is that these are both pink. No, it can't be the same either way. One is these are both pink, so this is not pink. Hold on, how did I get that that's 4 either way? I messed something up. Okay, these are, case 1. These are all pink, in which case purple is pink, which goes across from pink. Oh no, sorry, I did the first one wrong. No, sorry, that's right. Pink and pink, these are both 2 groups. 2 plus 2 is 4. That would make this 4. If this is blue-green, yellow is pink. Pink goes across from green, making this 6. Okay, sorry. I did the second part wrong. Okay. Yeah, so either way works. That's really, really frustrating. So hold on. If this is pink, what are the choices for yellow? It's either pink or this is pink. One of these are pink. If this is pink, what's yellow? Pink makes this 4. This goes across from green. Okay, so it's blue. So this is blue or pink. If it's pink, these become a green blue. Well, I guess I can probably figure out. Yeah, I mean, all of these are, at this point, I think everything here is just one of 2 colors. So should I change the pink yellow and get a dual color system going on? I think that's too much. Okay. So there's either 2, 8. I'm not gonna put them both in. I feel like I should be able to construct one of these, but I can't get there. Okay, I have a 4 here somewhere. Oh, sorry, I was doing this, I was doing all that here. That's not, it's here. It's this one. And I don't know anything about this, but I do now know that it's not in the 5 group because there's two ways around this can go, depending on whether this is double pink or green blue. And either way, you match up with one of these. So this isn't the 5 group. Okay, so this is greener. That seems worth marking because it's a central square, but literally and on the zipper. Um, okay. So what am I actually supposed to do next? Oh, I can finish this coloring. So this is um, pink, pink. So oh, purple. Ah, there we go. Purple is not green or blue now. Wow, that is cool. Got 1, 2, 3, 4. So it's 1, 4, 5. 1, 2, 3, 4, 5. Yeah, okay. That's right. So these are purple. So purple is now pink. And which way did that go with? Um, if this was green, blue, this was pink. So these are in fact pink. Wow. Wow, 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 wow. That is neat, neat, neat. Okay, so now since these are pink and pink goes with pink, this is green because pink and pink make green. This goes across from blue and blue doesn't change it, so these must be green. That makes this blue and that makes this green and that makes this green. Wow, that is so cool. Okay, and then this can't be 9. This can't be 1. So it's either 3, 4, 5, or it's 6, 7, 8. Either way, it's going up. So this is 2 or 5. And then this is whatever's left over. I get a 1 down here for sure. Can this be 6 now? That would be, no, this can't be because this is 9. Oops. Because I have a 3, 6 pair in the row. Now this is 4. Oh, these are all green. I feel like another puzzle of his had all of these being the same. Maybe I'm misremembering. So I get 4 down here. This becomes a 3, 4, 5. This becomes a 6, 7. I can actually color these, right? So I don't know those two because I don't know the order of these yet, but these are both pink, which makes these both pink. This is blue, which makes this green. I still don't know this. Oh, I do know because this is a 2, 5 pair now. That's a 6, 7. Makes this blue. Oh, these are both blue. Okay. Yeah, I feel like we're basically dead now. At least with the hard stuff. But maybe I'm uh overstating it. Okay. This is either blue or pink, which makes this pink or green. It could be either. This can't be 9, so the 9. Oh, did I just say this can't be blue? Yeah, because these can't be the same. So this can't be blue, so it can't be 9. This can't be 9 by Sudoku. These are gone. So that's a 9, which is blue. And that's going to tell me which way these go. Because 9 goes with this one. So this has to be the green, which makes it 7. Makes this 6. 9 is one of those, but I know it's here by Sudoku, which tells me this color is green. Let's see, I definitely have 8 here. No, I don't definitely have 8 there. That's a lie. I feel like I should know some things that are definitely here, but I do not. Okay. There's 1, 2, 5, 8, 9. Oh, I do know something. 4. Okay. These sum to green, but I don't know these. Can I do something? I knew this was half. Was it half this or double this? It's not blue either way. It's pink. By that weird logic I did before with this thing. That's pink, which makes this 2 or 8. Oh, so I get a 2-8 pair in the corners. I doubt that was intended. That seems pretty complicated, but I'm going to use it anyway. Let's see. Was it these are 0, so this is 0. This is 2, so these are 1 in total. Oh, this is the same as this. No, sorry, not the same as this. This is 1. This is 0 because I need one of each to fill the row. And this is 1. So this is 1 less than this. So this is 3 or 5, which is 0 or 2. This is 1 or 2. It's not a 3 then. This is green or pink. So 3 is down here. This is probably a 3 per pair, but at least I get a 6 here. That's a 3. Can this be pink? Do I get too many pinks here? How would that work? If this is pink, this could be 2, 3, and a 4 over here. So if these are all pink, I get 2 pinks down here. That'd be okay. 2, 8 here. And then 1 pink here, which I definitely have. Yeah, that seems okay, actually. If this is green, it's 1. Whoops, this is 1, 2, 5, or 8. If it's 1, I get a 1 here. Oh, that's interesting. So if this is green, it's a 1, and that goes here. If it's pink, it's going to be 2 or 8 that goes here. And so this is 3, 4, and 1 or 2 or 8. 1 can't go in here with a dot because then I get 2, 8 over here. So there's no 2. One of 3 or 4 is on this dot. But they could both be a dot. So this could be a 2, 3, or 4, and this is 1, 2, 3, 4, 8. That's a lot. Okay. But I'm going to mark it anyway. No, there's definitely a 3 here, so there's no 3 there. Okay. I should have one digit that I know is here. That's 6. Not in the middle. That's not 6. Ah, yeah, that's not 6. That's not 6. 6 is here. And then if these are all pink, this is green. Those green or pink. Yeah, these are a green pink pair. These are green pink pair, and this is a pink blue pair. Yeah, it's all working out so far. Okay, to get to green, it's either double pinks or blue green. They can't both be double pinks. So at least one of these is a blue green pair. They could both be blue green pairs. I get pinks everywhere. Oh, this can't be 2 pinks. It could be 1 pink. Oh, does this have to be 2 blues? Well, so my choices are this is 2 blues or a pink green pair. If this is a pink green pair, no, it could just work, I think. If this is a pink green pair, I could have a green blue and a 2 pink. Yeah, I think that works out. Okay. Maybe I should just think about this in normal digits. So it's either 3, 6 this way, this 6, or I mean, it's anything. Yeah, that's too much. Okay, but this is 2. Oh, okay, sorry. This is 2, 8, just like before. So that's 5. 2, 5. 5 is up here, so 5 is down here somewhere. So one of these is pink, and so it's always green in the center. So these are going to go across from another pink somewhere. Oh, interesting. So because these are all the same, I'm actually wondering now if I've done this puzzle before. This feels very familiar, but I don't remember doing it. I didn't solve it. I don't have a solve in LMD, which I usually do if I I don't think it was featured on. Basically, if I do a puzzle, it's either from LMD and I usually put the thing in, or it's from Cracking the Cryptic, and sometimes I don't, but I don't think this was featured there. But anyway, what I'm seeing is that these three kind of align with these three, even though they're not on the same line because they have the same center, they effectively are. So I get, oh yeah, this five is probably going to go across from this four. I mean, all this tells me that, oh no, sorry, it's a pink. This pink is going to go across from a pink somewhere on this line. So there's either a 2 or an 8 somewhere on this line, which makes sense. I don't know if that's not helpful, but it will hopefully do something eventually. Let's see, all the blues are done. So this, yeah, this is just a green pink pair in the row and the column. Oh, I know this too. This is blue, so this is green. There we go. That's helpful. Now I have 3 greens here. So these are, oh, this is a pink blue pair, which it just is. Okay. So these are the same, whatever that is. Oh, they're the same digit actually, because this, where does this digit go in this? Oh no, it could go here. It could be 5 in those places. Yeah, that's what I said was wrong. Okay. So how do we keep going? Um, well, if this is pink green, we're done with pinks in the column. So if this is pink green, I have another green and everything else is blue. This can't be blue. So this would be green. I would get blues here. This blue makes this green. That's fine. This blue makes this green. I'd be done with greens here. It's getting very complicated. That all seems right. This is not blue. Oh no, it could be 9. I'm thinking. It could be blue. I was gonna say I had to have a blue here, but these can't both be blue actually. So I do have to have a blue here. Ah, so no. I have a pink and a blue so far. I don't have to have a green. This could be green. This could be 7. But one of these is 7. If this is 7, this is 7. Hmm. Pink, there's a 5 somewhere here. Not here. So that's not okay. This is different from green and not pink because 2, 5, 8 are taken. So this is blue, which means it's 3 or 6, which means this can't be 1, which means it's 4 or 7. That's 1. That's really interesting. Like it's surprising. Very surprising deductions. These are all green or blue. I don't know if that's helpful. I get, see, I don't, one of these is green, but what about this? This goes across from this, but this could be anything. If this is blue, I could have pink, green, either way. Yeah, it works either way. This could be anything, this could be anything. Is there some, now can I do something with like these all sum to 0? Because I know like these sum to 0, these sum to 0. I mean, this is what I started with, I guess. These all sum to 0. There's definitely a 3 in here. It's just, I can't, it's too hard to see for me. Yeah, I don't know. Okay. Let's go back to this. If this is green pink, I get a lot of blues. Two of these 3 are blue now. But it's not all 3. Okay, if these are both blue, what happens? Almost nothing. Almost nothing happens. These could both, okay, well, maybe think about it. If these are both blue-green pairs, that can't, these can't both be blue-green pairs because then I'm out of greens, so I'll have three greens. And then what do I put here? I have two blues, so I can't put two blues here. And I'm out of green, so I can't do a pink-green pair here. So this can't be both blue-green pairs. It also can't be both pink pairs because I need four pinks. So on these four digits, I've got two pinks, a green, and a blue. I don't know which of these is which, but I know that these four digits are two pinks, a green, and a blue. Now, if these are both blue, so in these five, I've got two pinks, two greens, and a blue. Yeah, so if these are greens, sorry, if these are blues, this is a pink green. If this is a pink green, this is a blue pink. No, I did that wrong. This is, if these are blues, it's a green pink. Yeah, this is a green pink, these are blues. Okay. Weird. So weird. Um, I don't know which of these seems more, because the blues actually tells me quite a bit. I gotta get a nine here. Like these are blues, this is blue green. Because I would get 3, 6, 3, 9 in this row. Oh no, that's wrong. 9 could go here. Don't know what I'm thinking. 9 could go here. I was thinking, oh, 9 can't go here. Oh, where's 9 in this row? It's not here. It's not here. It's one of these, and it's not on the dot. It's a 9. Good old Sudoku is my friend here. So if that's green, or sorry, if that's blue, this is green. And now I'm done with greens in this row. So these are all blue or pink. So this is a blue-pink pair. Because I get a 5. That's the only pink that can go here. So this is a blue-pink pair. This is a blue-pink pair. This is not 7 anymore. That's 7, which is green. One doesn't have to go in this place, any place in particular. This is a blue-pink pair. Oh, I already knew these were blues and greens. Okay. Still, that felt useful. This is 1 or 4. Oh, this is 1 or 4. That does put a little bit of pressure here. So now if this is pink green, oh no, it still could be anything. I think it couldn't be 2, 4, but it definitely can. It could be 1, 2, 2, 4, or 4, 8. That's fine. Oh, sorry. This I know this way this goes too. This is 5 and 8. There's definitely an 8 here now. So this is either 1 or 2. Let's delete the coloring there. I don't think it's helpful. 8 makes this 2, 8. And then I get an 8 over here somewhere. Sorry, let's go do some Sudoku. Like non-modular Sudoku. I get a 9 here. Okay, so my blue-green pair goes like this somewhere. With the blue on the bottom and the green on the right. This seems pretty restrictive, but I don't know how to do it. Well, if these are blue, this becomes green, pink. If it's green, pink, it's green, pink, because these would be blues. And these are, oh no, oh yeah, these are on a 1 group. So hold on, so it's either 3, 6, that's if they're blue. If it's green, pink, this is blue. So this is green. So it'll be 1, 4 here with 2 or 8 here. But not 2. By Sudoku, or 8. Oh my goodness. 6. This can't, yeah, there we go. I could have seen these two pinks meant I couldn't have a 5 pink on the dot, so this would have to be blues. 3, 6. These are blues. This is 3. Makes this 5, 3. Ah, yes. Now we really have it. This is not blue. How did this go? Pink goes across from pink. This has to be green. So this becomes a 1, 7 pair, making this 2. It's a 3, 4 pair, making this 1. That's green. That is, hold on. Did I know this all? No, these were different. This was, I had 2 choices here. This becomes pink. This now has 2 choices for me. This is either green or blue. It's either 6 or anything green. But I know that just from this 2, 5, 8, I guess. This can't be 2. This cannot be 1 anymore. This is a 2, 8 pair. Yeah, this is 1, 4, 6, 7. 6 is not here, so 6 is here. Whoops. This is green. This is 1 or 4. 7. Oh, it just doesn't work. I mean, it works perfectly. Okay. Now I feel like we really have to be close to done. This, okay, that. These are going to go together. These are going to go together. These are going to go together. This is pink, green in some order. Do I know which order? I don't think I do. If this is pink, it's 2. There's a 2 in one of these, actually. Do I know it can't be pink, green for some? Oh, I just know what this color is by Sudoku. This is pink. This is pink. So this is pink, which means it's not 9. Which means this is 9. Which means it's blue. Which means this is not blue, so it's green. These are blue. This blue means this is green, which is not 8. This could still be pink though. I don't know which of these is pink and green yet. Oh no, I have 3 pinks in the column. So that's green. That's blue, which means it's 3. That's 4, which is green, which I knew from this blue across from it. These are a pink blue pair. That's pink. So that's blue, and that's pink. I just really want to finish this coloring before I even do the digits. But I don't know if I can. Yeah, I can. This pink means this is also pink. This, whoops. This blue means this is green. In the row, the column, I'm missing a pink. In the row, I'm missing a blue. I'm missing a pink, and I'm missing a green. And now I can put in the digits. That's the 5. That's the 9. That's the 9. I guess I'm gonna, this 3, 6 studly pattern, I guess I'm gonna get rid of with this. Let's see. This should just fill itself in. Okay, that's an 8. That's a 1. That's a 4. That's a 2, 8. It's a 4, 1, 4. 1. There we go. We have 8, 6, 5, 2. 7, 7, 4, 4, 7, 1. This is 2. 5, 8, 5, 8. And then 8, 5, 8, 2. That's correct. Oh no! What did I do? Oh, I just did, okay, just bad Sudoku at the end. Hold on. Just 2, sorry, 2, 8. Not now I have finished. 4. I did this on the Flinty puzzle. I missed a hole. I missed 2 in a box. Then I just missed 1. Okay. Whew. No too bad Sudoku mistakes except the very end there. Amazing puzzle. I really, really enjoyed this. So thanks, Heliopolis. Thanks for watching, and I'll see you all next time.